Number 4, we're going to identify the oxidizing agent and the reducing agent for each of the reactions in number 3. Now remember, when you are identifying each of these agents, they are in the reactants for the problem. Now the species being oxidized is the reducing agent. The species being oxidized in A is this sulfate anion. In B, it's the manganese compound. This is the compound that underwent oxidation. When we wrote out the half reactions, the electrons were on the product side. In C, it's the anion, and in D, it's the aluminum. Now, again, you can double check these by going back through, see how the aluminum has an oxidation state of 0 on the reactant side for D. On the product side, aluminum has an oxidation state of +3, so it must have lost 3 electrons. So you can double check that way. Now that means the other reactant in each of these reactions, I suppose, is the species being reduced. So that is the oxidizing agent. Number 5, why is it not possible for hydroxide ion to appear in either of the half reactions or the overall equation when balancing an oxidation-reduction reaction? Well, that's your key right there. In an acidic solution, you won't have a hydroxide ion because a hydroxide ion is a base. And in an acidic solution, you would quench all of the base and push towards the acid. And when you quench that base, you form water molecules. Similarly, you cannot have a hydrogen ion in a basic solution because the base would neutralize all of those acidic hydrogen ions in order to form water molecules, and then it would be overrun with the base, the hydroxide. Number 7, why must the charge balance in oxidation-reduction reactions? Oxidation and reduction are chemical opposites, and so in order for one to occur, the other must occur. Now they occur with the same charge balance because we cannot make or destroy matter. We can only transfer it, and therefore the charges will have to balance. Number 8, balance the following in the type of solution indicated. So we have hydrogen and copper reacts to form solid copper or elemental copper in an acidic solution. So first we're going to write out our half reactions, and this one might be a little tricky because we only have the one product. But remember, we balance our hydrogens by adding hydrogen ions, so it'll work out. Now we need to balance our charges, and then we will have our overall reaction. So on the reactant side, we would have our copper cation, our hydrogen, elemental hydrogen. We would form 2 hydrogen ions and solid copper. For B, again with our hydrogen ion, and this time we have a copper hydroxide, and this is copper 2 hydroxide, reacts to form solid copper. Again, we have hydrogen. Then, well, we're going to need our copper here, copper hydroxide. And we balance all of our elements other than oxygen and hydrogen first. They're balanced. So now we'll go to oxygen, and I'll add my 2 water molecules. Then I go to hydrogen. I have 4 hydrogens on this side. I need 2 more hydrogens on this side. And now we do our charge balance. So I must have 2 electrons over here, and I must have 2 electrons over here to form an overall reaction. And this would be for an acidic solution. Now we would gather like items. I did not put the electrons in for brevity. We don't have any like items, but so this would be for an acidic solution. It specifically says for a basic solution, so I need to neutralize my acid by adding 2 OH anions to both sides. That gives me 2 water molecules on the reactant side, along with my other reactants. Now I can cancel out both sides, 2 waters on both sides. So I have this is my final reaction. I have elemental hydrogen plus copper 2 hydroxide reacts to form 2 hydrogen cations plus elemental copper plus 2 hydroxide anions. Now I'm asked to identify the oxidizing agents and the reducing agents. So the oxidizing agent is the thing being reduced, and the reducing agent is the thing being oxidized. So let's go with the oxidizing agents first. Again, the things being reduced. So we're going to have copper, because the copper 2 is reducing to a copper 0. The electrons in the half reaction were on the reactant side, so that's the reduction, and that makes the copper the oxidizing agent. Same for B. And in C, I haven't done C yet. I'll get to C. So the reducing agent is the hydrogen for both A and B. Now let's work C. We have iron and silver 1 react to form iron 2 and silver. Do our half reactions. We don't have any oxygen or hydrogen to worry about, so we just need to do our charge balance. Multiply this half reaction by 2. Get our overall reaction. And that would be the overall reaction for both an acidic or a basic solution. So the reducing agent is the thing being oxidized, so that would be my iron. And the oxidizing agent is the thing being reduced, and that would be my silver.